Right, one more example before we look at doing things on slopes. So we're going to have a ball which is projected upwards with initial velocity 20 meters per second, and then it goes up 16 meters vertically, and that's the top of its motion. So velocity there is 0 meters per second, and there's some air resistance acting on the ball, so we want to find the magnitude of the air resistance. So we're going to use the work energy principle. So the change in total mechanical energy of a particle is equal to the work done on the particle. So we've got this kinetic energy which is being lost, and we've also got some potential energy which is being gained. And if there was no air resistance, those two things would be equal, which is what you were doing at the beginning of the lesson, or your work on this. But because there's some air resistance which is acting against the motion of the ball, so we've got this air resistance slowing it down, it's not actually going to get quite as high as it would. So to find the change in mechanical energy, we need to look at doing the kinetic energy lost, take away the potential energy gained. So change in mechanical energy. So I forgot to give you the mass of the ball. So the ball is going to have a mass of 0.1 kilograms. So change in mechanical energy. So we've got loss in kinetic energy, take away the gain in potential energy. I'm quite sure I didn't just write PE there, but never mind. So loss in kinetic energy is a half times the mass times the speed squared, and then I could take away half times 0.1. I mean, this one stops, so I'm just taking away 0 here. And then the gain in potential energy is the mass times G times by H, which is 16. So if we work all that through, 0.5 times 0.1 times 20 squared is equal to 20, and then I'm taking away 0.1 times 9.8 times 16, which is 15.68. Which gives you 4.32. So the work done by the air resistance is equal to 4.32 joules. One thing to note with these is if you think about the forces acting on this ball, we've got the resistance, which is slowing down motion, and we've also got the weight. But when you're working with energy problems, the weight is basically your work done against gravity, which is wrapped up in your potential energy. So that's part of your mechanical energy. So you don't consider the weight because we've considered the weight here with this gain in potential energy. So you're looking at external forces. So gravity is a conservative force, and that counts as being within this change in mechanical energy. So work done. By air resistance is equal to 4.32, and that is equal to the air resistance R times by the distance travelled, which is 16. And so the magnitude of the air resistance is 4.32 divided by 16, which gives you 0.27 newtons. So it all balances out basically. So if you could have a go at doing, on that same exercise, question 16, and I'll get your page number in case you need it. So it's a Further Mechanics 1 book, exercise 2C, page 28, probably, by the time we get to there. Yeah, page 28. Question 16, which is similar to this. Remember, impulses changing momentum. And then next lesson we'll bring in resolving on slopes as well.